Hello viewer, welcome to this session of physical chemistry. In this session, we will discuss on liquid state of matter. Liquid is, as you all know, liquid, what we drink liquid is found anywhere, everywhere, and a most essential part of our life is liquid. In this session, we will discuss on attraction forces which occurs in liquids, intra and intermolecular forces, strength of attraction, types of intermolecular forces, London dispersion forces, dipole-dipole interaction and hydrogen bonding. Let us start with attraction. What is attraction? The very strong intramolecular forces include polar and non-polar covalent bonding as well as ionic bonding. It takes high temperature to break apart intramolecular attraction. Intramolecular forces occur within molecules, substance such as HCl, a polar covalent bond between hydrogen and chloride within a molecule. Intermolecular forces are weaker attraction that hold molecules or noble gas particles close together when they are in liquid or solid form. An alternative name for intermolecular forces is the van der Waals forces, which we will discuss later on. Here is the picture which show inter and intramolecular forces. Where is inter and where is intra? Here HCl, the two molecules of HCl, here we see in the picture two molecules of HCl, the H and Cl, the bonding between H and Cl is a covalent bond, that is intramolecular attraction. Intramolecular attraction within the molecules, it is a molecule of HCl, the intramolecular forces in H and Cl bed, and the attraction between two molecules of HCl, this one is known as intermolecular attraction, that is a weak attraction. Strength of attractions. The strength of attraction influences the state, whether it is solid, liquid or gas of substance. Stronger attraction will strongly hold together in a solid from until enough energy or heat or temperature is added to break the attraction and liquefy. It means a solid needs temperature or heat, then it converted into liquid. With more energy, thermal heat or higher temperature, when we increase, all the intermolecular attraction will eventually be overcome to form gas particles, that is boiling point. A heat a liquid, it converted into gas by giving the energy, that is heat or thermal energy. Particles held by very weak attraction are often gases at fairly low temperature. The particle in gases, we see the particles or molecules in gases are very weak, having very weak attractions. So, they are in gaseous form. Have you ever thought that why is CO2 a gas at room temperature and H2O a liquid? Why do liquid have different boiling points and what causes molecules to stick together when in liquid? Answer is attraction forces called intermolecular forces exist between molecules. Now, we discuss on type of intermolecular forces. There are three types of intermolecular forces. The intermolecular forces in liquid are collectively called van der Waals forces. There are three different types of intermolecular forces in molecules presented in the order of increasing strength. That is, first one London dispersion forces, and second dipole-dipole interaction, and third one hydrogen bonding. As we mentioned earlier, presented in the order of increasing strength. That means hydrogen bonding is more strengthable than dipole-dipole, and dipole-dipole is more strengthened than London dispersion forces. Relative strength for the different interaction. The strength of the intermolecular forces determine whether a compound has high or low melting point and boiling point, and thus if the compound is a solid, liquid or gas at a given temperature. So, relative strength decides whether a compound is solid, liquid or gas. The relative size of these interaction is important, so the relative effects are understood. Here are the comparison of 4 attraction, that is London dispersion forces, dipole-dipole attraction, hydrogen bonding and covalent bonding. We can see the covalent bond is more strengthened than that of intermolecular forces, and intermolecular forces hydrogen bonding is more strengthened than above of 2 London and dipole attraction. Now, come to the first intermolecular forces, that is London forces. What is London forces? This is also known as dispersion force, London force or van der Waals force. The nature of dispersion force was first recognized by Fritz W. London, a German American physicist. Attraction are caused by instantaneous dipoles, that is temporary dipoles created by the uneven distribution of electron within the particle at any instant. The temporary dipole in one particle will induce an opposite temporary dipoles in the nearby particles. The temporary partial positive and partial negative charges that develop between particles from the attraction. London dispersion force are very weak interaction due to the momentary changes in electron density in a molecules. For example, while the electron in the first s orbital of helium would repel each other and therefore tend to stay far away from each other, it does happen that they occasionally wind up on the same side of the atom. From this picture, it is clear that a helium atom where the 2 electrons comes in a side that create partial negative charge and second at created partial positive charge. At that instant, then the helium atom is polar with an excess of electron on the left side and a shortage of on the right side. An instantaneous dipole on any one helium atom induce instantaneous dipole on neighboring atom. The neighboring atoms that attract one another. This attraction is called dispersion forces or London forces. From this picture, we can see easily that helium atom in which the partially positive and negative charge occur, they attract another helium atom by weak attraction, that is London forces. Here is another diagram which elaborate the London forces. These forces are present in all molecules, whether they are polar or non-polar. The tendency of an electron cloud to distort in this way is called polarizability. The larger the molecule, the larger the attractive force between two molecules and the stronger the London forces. In a non-polar molecules or atom, the electrons are constantly moving and it may be regarded as an oscillating system of electrical charges. So, London forces is partially occur in non-polar molecules. If the electron cloud at any instant is even slightly displaced relative to the nucleus or nuclei, a small instantaneous dipole develops which cause instantaneous induced dipole in nearby molecules, resulting in a small attractive force called dispersion force or London force. The potential energy due to the dispersion force or London force is given by the formula UD is equal to minus 3 h nu alpha square upon 4 r 6, where r is the radius, h is the Planck constant, nu is the frequency of oscillation of electron cloud and alpha is the polarizability of the molecule or atom. Now, second interaction, dipole-dipole attraction. This is the second intermolecular forces. Such interaction occur in polar molecules. Take the example of HCl. It is a polar molecule with one end having a partial positive charge and the other having a partial negative charge. Here hydrogen have partial positive charge, whereas chlorine have partially negative charge. Such molecules are called dipoles. The positive end of one molecule attract the negative end of the another. There is a net attraction force between polar molecules. Such attractive forces are called dipole-dipole attraction. The intermolecular forces is weak compared to the covalent bond, but this dipole-dipole interaction is one of the stronger intermolecular attraction. Although dipole-dipole attraction is weak in comparison to covalent bond, but it is more stronger than London forces. Here the HCl, here the two molecules of HCl, H and Cl, H having the partial positive charge and Cl having the partial negative charge, and the attraction between chlorine and hydrogen, the dipole, that is known as dipole attraction force. When a liquid contain molecules with permanent dipole moment, for example HCl, H2O, etc., the molecules attract each other by electrostatic attraction. The negative end of the one molecules attract the positive end of the another molecules and vice versa. The orientation of molecular dipole is such that ends of opposite charges are close to each other, while the ends of similar charges are far apart, as given in the diagram. This one here, the positive and negative charge are come closer, whereas the negative and negative charge repel each other. These interactions are significantly even at reasonably large distance and produce orientation effect in the substance. It means dipole-dipole movement, dipole-dipole attraction can move a molecules here and there. The melting and boiling point of substance are influenced by this type of interactions. The melting and boiling point of substance can be increased or can be decreased by knowing the dipole-dipole movement of that substance. The substance which no dipole movement have lower melting point or boiling points than polar substance. The dipole-dipole interaction leads to a potential energy given by U is equal to minus 2 mu power 4 by 3 r power 6 kT, where U is equal to the potential energy, r is the distance separation of dipole, mu is equal to dipole moment, k is the Boltzmann gas constant. By this equation or by this formula, we can, knowing the dipole moment, one can measure the potential energy of that compound. Here is a table which show the more polar the molecule, the higher is its boiling point. Here acetonitrile having the molecular weight 41 and dipole moment is 3.9. The boiling point is 355 Kelvin. Here from this table we can see the acetonitrile having the low molecular weight than that of methyl chloride or acetaldehyde, but the dipole moment is more than that of this compound. So, the boiling point of this is higher than that of other molecules. It is clear, the more polar the molecule, the higher its boiling point. Now, third intermolecular forces, that is hydrogen bonding. It is a special type of a dipolar interaction. The irregularity in boiling points trends is due to a particular strong dipole-dipole force called hydrogen bonding. Hydrogen bonding occurs between molecules that contain hydrogen covalently bonded to either nitrogen, oxygen or fluorine. Nitrogen bonded to hydrogen, hydrogen bonded to oxygen, hydrogen bonded to fluorine. Hydrogen bonding causes boiling points to be much higher than expected. Hydrogen bonding is a special case of dipole-dipole forces. It occurs when hydrogen is directly attached to a small highly electronegative atom such as fluorine, oxygen or nitrogen. It occurs when hydrogen is directly attached to a small highly electronegative atom such as fluorine, oxygen or nitrogen. Due to the electronegativity differences and small size, hydrogen can develop a permanent partial positive charge and the fluorine or oxygen or nitrogen atom will develop a permanent partial negative charge. Interaction between two separate particles will strongly attract the opposite charges. The dipole-dipole interaction experienced when hydrogen is bonded to nitrogen, oxygen or fluorine are unusually strong. We call these interaction hydrogen bond. When hydrogen is bonding with nitrogen or hydrogen bond with oxygen or hydrogen bond with fluorine, it called hydrogen bonding. Hydrogen bonding is a special type of molecular attraction between the hydrogen atom in a polar bond and non-bonding electron pair on a nearby small electronegative ion or atom, usually fluorine, oxygen or nitrogen. Hydrogen bonding arises in part from the high electronegativity of nitrogen, oxygen and fluorine. Hydrogen bond is the strongest of all intermolecular forces, including the dipole attraction and London forces. It means out of 3 intermolecular forces, the hydrogen bonding is much more stronger than that of dipole attraction and London forces. Here is the diagram which show the hydrogen bonding between 2 molecules of water and hydrogen bonding showing in ammonia and water, hydrogen bonding in ammonia and ammonia molecules, ammonia and water molecules and ammonia in water molecules. Here is the hydrogen bonding in H2O. This is a 3-dimensional structure of H2O which show the hydrogen bonding, which is showing by the dotted lines. Here the dotted line which show the hydrogen bonding in between oxygen and hydrogen. Here is the hydrogen bonding in hydrogen fluoride HF. Here H and F, where H have the partial positive charge and F have the partial negative charge, the bonding in between, that is hydrogen, fluorine and hydrogen, that is hydrogen bonding. Now, summarizing the intermolecular forces. Here is the chart which show what kind of attraction in the molecules or in the ions or in the compound. Interacting molecules or ions, if interacting molecules ions are ions involved, in this ion only ion are involved. If only ion are involved, if it is yes, then are polar molecules and ions both present, then if yes, then ion dipole forces, example KBr in H2O. If polar molecules and ions both are not present, then ionic bonding, example NaCl, NH4NO3. And now come to are ions involved, the ion are not involved. Are polar molecules involved? If yes, are hydrogen atom bonded to nitrogen, oxygen and fluorine atoms? If yes, then hydrogen bonding. If nitrogen, oxygen and fluorine are bonded to hydrogen, then it is hydrogen bonding. The example are H2O, NH3, HF. If hydrogen atoms bonded to nitrogen, oxygen or fluorine, if this is not occur, then dipole-dipole forces, example H2S, HCl. If the polar molecules are not involved, then dispersion forces only, Ar and I2, and the dispersion forces and dipole forces and hydrogen forces cumulatively is called van der Waals forces. All 3 are called as van der Waals forces. Here is another which distinguishes between hydrogen bonding, dipole-dipole forces and London forces. Here the white portion, molecules which H and F, H and O, hydrogen and oxygen, hydrogen and nitrogen bond, these are called as hydrogen bond. Another polar molecules show only dipole-dipole forces and London dispersion forces, all molecules show London dispersion forces. Trends in intermolecular forces strength. When determining which substance has the stronger total intermolecular forces or the higher boiling point, if we want to say what kind of how much boiling point is in this compound, in this liquid, then follow the following guidelines. First, look to see if the substance can hydrogen bond. If so, it likely has the strongest intermolecular forces if there is a hydrogen bond. Second, if you are comparing two molecules of different molar masses, then London dispersion forces are more important. And if you are comparing two molecules of very similar molar masses, then dipole forces are more important. Now, we are come to the conclusion of this session. In this session, we have discussed attraction forces, intra and intermolecular forces. We have discussed strength of attractions, type of intermolecular forces, London dispersion forces. We also discussed dipole-dipole interaction and hydrogen bonding. This is